which is being known as CMOS relay. I use it to develop circuit. Let me show you an example of what I'm talking about. I come here, I come to my menu. Let me see. Let me show you what I'm saying. As you can see, this is star data. Bring the camera close. Let me let them see. The circuit you see that is being displayed on the screen here, it is star data, 2 cents of rotation. Yes, this starting method is a suitable starting method which is mostly recommended for large induction motor due to an ability to reduce the starting current. Because in induction motor has a very high starting current. So in order to reduce the starting current, we implement this starting method, star data. It reduces the starting current. And remember, whenever current in an installation, when the current is high, the voltage is very low, and with the voltage being equipment. Now in the field of electrical power system, you do not focus on your own safety. The safety of the equipment and appliances, in fact in general electrical accessories, need to be your top priority as well. Let's see how this circuit diagram operates. Now I will play it. When you take a good look at this level, you will see that this is the fuse isolator. Before I proceed, I would love to share with you the various components that was put together to form this circuit. It is what we call, this is the phase. Maybe this is the supply source. Now we have line 1, line 2, line 3, and the neutral part. Under there we have what we call fuse isolator. Now the role of the fuse isolator is to protect the entire circuit against excessive current due to short circuit. Now when we talk about short circuit, what do we mean? Short circuit, it is a drastic increase in current from 10 to 100 times more than its nominal value when 2 or more active conductors from different polarity or different potential that does not supposed to come in contact touches accidentally without passing through a load. Some sparks, those sparks are called electric arc, which is the ionization around the surrounding air that has been made live whenever coil is being switched on or off. In order to avoid such situation, we always use our protective device. The protective device to protect against such problem, it is a fuse isolator. Since we are dealing with 3-phase, you can see it. Bring the camera closer. That is it. Below the fuse isolator, we have our main contactor, our main forward contactor, and our reverse contactor, which is denoted as KM2. Our main contactor is KM1. Now below this we have a thermal relay. Yes, so maybe bring the camera this way. Now a thermal relay, it is also a protective device, but now at this level it is designed to protect only the motor against overheat. You get that? Maybe I want you to see how things are going. The safety of your equipment, it needs to be your number one priority. Don't play with your protective device. Put them wherever they are needed. You get to avoid further damage. So this thermal relay is being put in place to protect only the motor against overheat. Because let me see what are some of the things that can cause overheat in an induction motor. Yes, maybe the shaft, the bearing at the level of the shaft is maybe the bearing has you have a bad bearing, and as a result of that it does not rotate very well. Because the rotor cannot rotate very well, it cannot rotate smoothly, that will definitely stress the winding, and hence a lot of energy will be dissipated, and because as a result of that, that's an overheat, and if it prolongs, the coil will get burned. To avoid this situation, we introduced thermal relay. Yes, let me say, now here's our motor. Now under we have our star contactor. Under the motor we have our star contactor. Here we have our delta contactor, and here is the control circuit. Come closer with the camera. When you take a good look at here, this lamp here indicates the presence of supply, which it is indicated as A6. Now if you see here, this is the auxiliary contact of the thermal relay, which indicate the faulty lamp. This is the faulty lamp, which is denoted as H5, and here is the delta. This H4 signifies that the motor is running either in the forward or reverse direction with the stator winding connected in delta. Same here is the inverse of this. This one will indicate that the motor is running either in forward or reverse direction with the stator winding connected in star. This one will indicate that the motor is running in reverse direction. This one indicates that the motor is running in forward direction. Let's simulate and see how it operates. I will close the fuse isolator. Now when I close the fuse isolator, you will see that the lamp here indicate the presence of the supply is already on. Now let's excite the coil for the forward contactor and see how the circuit will behave. By exciting the coil on the forward direction, an action is needed on S2. Now you will see that the motor is running in the forward direction with the stator winding connected in star. That is why you are seeing here. Now after a predetermined time, says the timer, it switches from star to delta. Now you can see this, the motor is running still in the forward direction with the stator winding connected in delta. This indicates that the stator winding is in delta and forward direction. Let's stop the movement. Now we have our emergency stop push button. We have our stop push button. We will stop the forward movement. Now let's drive in the reverse movement. Drive the motor in the reverse movement and see. Now the motor is running in the reverse direction. You can see even from the arrow from the motor with the stator winding connected in star, it has switched. Now it's still running in the reverse direction with the stator winding connected in delta. If you are new, focus on me now, bro. If you are new, but it's your very first time coming across my video, I will appreciate your share and drop your comment for further clarification. Thanks very much. I appreciate.
Thank you very much, Mr. Desmond, for this wonderful explanation based on your field. I've seen that you know more about this engineering field, and your explanations are really deep in such a way that even someone who is a beginner wants to learn this field can easily understand what you just explained. And I'm sure so many hiring managers out there, once they see your video, they would like to get in touch with you, get in contact with you. Thank you very much for this wonderful explanation. Thank you.